Today's lesson is on functions, tables, and graphs. Let's review some vocabulary words. First of all, a function operates according to a rule to produce exactly one output value for each input value. An input value is substituted into the function, where the output value is the result from the substitution. A function rule is the result. A function can be represented by a rule written in words such as double the number and add 9 to the result, or by an equation with two variables. One variable represents the input, the other represents the output. So you can see here we have an equation where we have y is equal to mx plus b. This entire equation is called the function rule. The y value is always our output variable, while the x value is our input variable. Let's take a look at some examples. So you can use a table to organize and display your input and output values of a function. So we're going to complete this table. It's not as hard as it actually looks. Our x values are already given. You can see that these input values, or x values, are -1, 0, and 3. Our rule is right here in the middle. So that comes from right here. The y value is what we get as the output once we input the x values into the equation. So let's try a few right now. So you can see with the rule being here in the table, I can replace x with each one of these values. So I'm going to go ahead and do that. I'm going to keep the 4 right there. Instead of x, I'm going to replace it with that -1 and then keep the rest of the rule. Then I'm just going to follow order of operations and see what I would get from that. 4 times -1 is -4. -4 subtract 2 would be -6. Now, if you need to write out the information over here, you can also do that. Let's put in 0. So 4 is staying put, 0 is replacing x, and subtract 2 is the rest of the rule. Following order of operations, 4 times 0 is 0, 0 take away 2 is -2. Finally, we have 3. I'm going to keep the 4 once again and replace the x with the 3 and keep subtract 2. So basically when I'm doing order of operations, I'm just multiplying 4 and 3, which is 12, subtract 2 is 10. So you can see we completed the table and it really wasn't as hard as maybe it looked. So one thing I want to point out is right here. Reviewing all the x values, I can tell that this actually represents a function. Now I can tell that because none of the x values actually repeat. And this is a very common question asked of students, and one of the easiest ways to tell whether or not you have a function is just to review all of your x values. If none of them repeat, you know you have a function. What would also happen if we graphed this, it would be a complete straight line. So I would also be able to tell it was a function if I graphed it. But a really quick way just looking at a table is just to see if your x values repeat. It's okay if the y values repeat, but not the x values. So this is a function. Let's take a look at another example. This time it looks like my rule is 8x plus 5. They did give me all of the x values, and check it out, none of them repeat. So I'm going to replace each x value into the rule to determine what my output or my y value is. So let's go ahead and get started. I'm going to keep the 8 each time and replace the x with the x value. So that in this one it's -4 and plus 5 comes here. So over here we'll use a little room to work. 8 times -4 is -32. If I take -32 and add 5 more to that, I would get -27. Remember the rules for adding integers. When one is negative, while the other is positive, you have to find the difference between the two and keep the sign of the higher absolute value. So if I find the difference between 32 and 5, it is 27. Since I have more negatives than I do positives, it is a negative answer. Okay, moving on. I keep the 8 again, replace the x with a negative 2 this time, and add 5. 8 times negative 2 is negative 16, plus 5 would give me negative 11. In the last one, x is equal to 1, so we'll replace that and then add 5. 8 times 1 is 8, plus 5 would give me 13. Okay, now let's decide whether this represents a function or not. So take a look at your x values. It looks like they don't repeat, so this is a function. If one of those x values repeated in this table, then we would say that it is not a function because it would not form a straight line if we graphed it. Let's move on to the next example, and you're going to get to see some of those functions actually graphed. So in this example, our rule is 3x plus 2. You can see that here in the center, and they did give us all of our input values or x values. So let's replace the first x with a negative 3 and keep the rest of the rule. If I do this problem, 3 times negative 3 is negative 9, plus 2 more would give me a negative 7. Again, replacing the x, this time with a negative 1. 3 times negative 1 is negative 3, plus 2 more is a negative 1. And then finally replacing x with a 2, I get 3 times 2 is 6, plus 2 more is 8. So again, I'm just going to check my x values and see if any repeated. They didn't repeat, so this is a function. And another way you can tell whether or not you have a function is to actually graph it. So right here I have an input value of negative 3 and an output value of negative 7. In a previous lesson, you learned how to graph the coordinates. So we're going to graph negative 3, which is x, and negative 7y. So that coordinate is negative 3, negative 7. So I'm going to start at the origin, I'm going to move to negative 3, and then I'm going to move down to negative 7. And I'm going to plot my first point. I'm going to graph the next one, which is negative 1 for an x value and negative 1 for the y value. So again, start at the origin, move left to negative 1, and down 1 to negative 1, and there's my second point. The last one is 2, 8. So we're going to start at the origin, move to the right to positive 2, and up to positive 8. So there are my 3 points. Now, ideally, I would be using a ruler to connect these points, but because I don't, this is probably not going to look like a really straight line, but I'm going to do my best to connect my points. And it's really important that you put arrows at the end, and there's my straight line. So if it is in fact a straight line, it is also a function. Let's take a look at another example. In this one, I have negative 2x as the rule, and here are all my x values. I can see that nothing repeats, so I already know that this is a function, but I'm going to go ahead and figure out what the line is going to look like. So when x is negative 2, I'm just going to replace it. Negative 2 times negative 2 is a positive 4. So when I graph it, I'm going to be graphing negative 2, positive 4. So I'll just go ahead and do that, and there's my first point. In the next one, x is 0, so 0 times any number is automatically 0. So it looks like the next point I'm going to actually graph, 0, 0, happens to be at the origin right there. And the last one we have 4, so negative 2 times 4 is negative 8. So I'm plotting 4, negative 8, starting at the origin, moving right to 4, and down to negative 8. And once again, if I connect these points, you're going to see another straight line. So please make sure you're using a ruler when you're doing this on paper and pencil so that you have a completely nice straight line. and it is a function. 1, because no x values repeat, and it also graphed a straight line. Let's check out another example. This time we have an exponent in here. So when we replace x first with -10, we have to make sure that we raise it to the second power. So we want to do this first because you always do exponents before you do multiplication. So -10 times -10 happens to be 100. 100 times 3 is 300. In the next one, we have 3, open parentheses, -6 squared. This we would do first. -6 times -6 is 36, and 36 times 3 is 108. And finally, we have -2 squared. That would be 4 times 3 is 12. I can tell here that none of the x values repeat, so I know that this is a function. Now for this one, I'm actually not going to graph it just because I have such big values here, and I don't have a large enough graph to do that. You could maybe try graphing this on a sheet of paper if you wanted to maybe go up by tens, just to see what it would look like. But since I already know that the x values do not repeat, I already know it is a function. Okay, thank you for watching this video.